One of the lessons that we learned was on range requirements. A lot of the range requirements that we were working from a vehicle perspective with the range were developed and presented to the range in a package pretty late in the entire process. The vehicle requirements from a range perspective drive a lot of the operational requirements that are responsible by the test team. For example, the launch flight hazard areas and some of the clears, as well as some of the personnel that are required to be inside of those areas, are directly driven out of those other requirements that come from the range once we have determined from a range perspective what those requirements would be based on the inputs that come from, say, 1X. So as a result of that, some of those things came very late, created a lot of lateness in some of the procedures and things that need to be done. As a lesson learned, certainly we would like to have those things done as far in advance as possible so that we can put those procedures in place, practice those, and work those out through the test teams and have everybody briefed and understand what those procedures, requirements, and capabilities are for any new vehicles or any other vehicles that would be coming down the range.
One of the other areas where we would have loved to have gotten the requirements in early was in our dealings with the range. The range needs a lot of time. There's a lot of things the range has to do. Now, we've gotten very used to dealing with them on the space shuttle. It's a well-known spacecraft, rocket, and they also with Atlas and Delta. These are ones that the range knows very well. The parameters change somewhat from mission to mission, but it's much easier for them to go deal with them. With Ares 1X, we were a brand new rocket. They needed a lot of information in order to do the proper analysis and modeling that they have to do to establish range limit lines and blast danger areas and things like that. Because we were unfamiliar with their need for that much information up front, because we've gotten used to doing it in a later manner with the shuttle, because they were used to the shuttle, we didn't get the data to them in time.
I think the lesson learned here is to get your requirements in as soon as you can so the supplier can say, yea, verily, I can meet this, or no, I can't. It's going to cost you this much money. Get the work document number on the requirement so that when the schedule comes out of what jobs are going to be performed when, the supplier looks at that schedule and says, oh, I got to provide cameras today, I got to provide comm today, I got to provide data to go out to a different center today, and they know ahead of time. They can plan their schedule ahead of time.
And one of the other lessons that we learned in 1X and when we demonstrated in 1X was with our with the launch team structure. We were able to put a very small launch team in what we considered a badgeless society. And as a badgeless society, I mean we had engineering personnel from many different companies, many different teams working together side by side that were from different launch programs working as part of the Ares 1X launch team. So as a result of that, all of the members were considered badgeless and all part of that same team and worked well together. The small team that we had was comprised of about 31 people in the prime launch team, and they were responsible for implementing all the launch commit criteria that we needed in order to, on launch day to commit the vehicle to launch. In addition, they were responsible for configuring all of the systems and making sure and validating that they were prepared and ready to go as well. There were several other teams that were supporting that prime launch team on launch day, providing engineering expertise and also some management expertise as well that may have been required for certain conditions that would have required a waiver. And they were located in locations behind our firing room and also at some of the buildings pretty far away from where we were at geographically. As one of the lessons learned for the next program, we'd like to see certainly a co-location of the teams that have to work very closely together, i.e. our launch support team and our prime launch team, who work hand in hand whenever there's a technical issue for troubleshooting or Tiger teams or any other problem resolution development.
One of the things we wanted to establish and really demonstrate is that we could have this badgeless environment when our heritage in the shuttle program had said that that wasn't the model that we had used. So we set it up, and so I got to participate as the launch vehicle test conductor. There were 5 or 6 contractor personnel who also held that same exact title, and that mainly was because we had operations that went multiple shifts and over several weeks where we had to do integrated testing. And even for launch countdown for Ares 1X, we had to support several shifts leading up to the final, what we call terminal count, which led to launch. And so we had launch vehicle test conductors running procedures and working through the testing that needed to occur prior to launch. And then myself and Rudy Tench, my contractor counterpart, came in and worked that position through launch countdown and through launch. And we had a very good working relationship, being NASA and contractor. We interchanged different responsibilities and roles. We sit in place of one another in different meetings, and it was very seamless. We did that very well. And our position was not unique. We did that in several positions as a part of the integrated test team and launch team, that you had NASA and contractor engineers working the same console position, and they each had the same level of authority and understanding of their system and the requirements that they had to go meet. And I think it was a very good experience for me, and I think it was a good demonstration and a good lesson that this is a good model to work from. And I would definitely recommend that as a very good option for any new programs that were coming on.
One of the other things that we learned about the firing room in the development of it is when you develop and put together the hardware that you need in a particular firing room, doing that very far in advance of when you're actually going to be needing that hardware sometimes precedes when you've actually defined the folks that are going to be using it. So what happens is, as was in the case in 1X, you develop a firing room in which, as the requirements change and as you get closer to where you're actually going to be needing it, more functions are developed, more systems may be needed to be monitored, and there may be some things that you hadn't considered. So by developing and putting firing rooms together at such an interval so far in advance of when they're needed, you may end up with space limitations or without the space that you need to adequately, support all of the test team members that need to be there. But the converse of that is also true. One of the lessons that we have is that you do want a firing room there far enough advanced so that you can train the teams, because that we found was very critical and very essential and very important to how well the team performed later. The ability to train them and also to go through the procedures and validate those against some of the actual flight hardware that you have maybe in one of your labs or on a rack somewhere, where you can actually send commands and see how the hardware behaves to make sure that your procedures, the sequencing, and all of the work that is associated with those is in the right order and that it is functioning in the way that you expect. And so as a result of that, you do want to have your firing room far enough advanced so that you can do all that with your procedure valves as well as the training of your teams, but not so far in advance that maybe you've overlooked some of the things that you may need to be able to support those teams.
To tie into that lesson, one of the other parts of that was developing the training plan for those folks that were going to be in the Launch Control Center on launch day and we're going to be sitting at each of these console positions. And so that training plan incorporated not only the console engineers who were running procedures against their systems, but it also covered the test conductors for the launch vehicle, test conductors for the ground systems, the test directors who were orchestrating all of the operations from a center-wide as well as interaction with areas off the center, as well as the launch authority team, who really are the management and agency level personnel who basically give that final go, yes, you have the agency's authority to go launch that day. And so in developing that training plan, we were challenged by the fact that who was going to be on that launch authority team and how each center was going to be and all be incorporated, how each piece of Ares 1X, because it was a distributed design and a distributed effort, everybody wanted to be included in that final decision. And getting to who that final launch authority team was going to be took a long time. And so it really delayed getting that training plan established.
One of the other things that we learned as a result of actually going through the launch countdown We did a lot of training with our launch authority team with our regular prime launch team to ensure that we had good communications and good skills. But there were some of the roles and requirements that that launch authority team, who had direct authority to give the go for launch to our team, that weren't defined until very late in the processing phase. So as a result of that, some of those changes were not as well practiced or rehearsed as they perhaps could have been had we had those in place well in advance and could have practiced those in more sims than we had. So the lesson learned here is that we should make sure that as we go through and define those things, first of all, that we have very clear roles and requirements defined for how those teams are going to operate separately, and more importantly, how those teams are going to interface together on launch day especially, because you don't want to be on launch day and have to come up with new plans, requirements, or figure out how those roles and communication paths are going to work when you're actually trying to launch the vehicle.
One of the lessons that we learned, and I think we knew that there were going to be some challenges, but one of the lessons that we learned was that when you have an existing program like the Space Shuttle program, and now you want to bring another program or another launch, a flight test launch, into the same facilities, into the same center, and you're going to share not only facilities but also personnel and other resources at the center to accomplish both missions. The existing program that's been around for many, many years really has a priority at the center, and that was what we found. And so when it came to the time frame in which we were getting the Ares 1X hardware on base, and we were starting to integrate the pieces and getting to the point where we could do that integrated testing from the control center, we really had to compete with the STS-129 space shuttle mission processing that was going on the other launch pad, not only from a personnel perspective, but from many other resource allocations. So the priorities for which mission was going to get those personnel first, that priority really wasn't set. We were trying to deconflict it the best we could at the lower levels, and we were able to do that to a great extent. But when it came down to having a space shuttle vehicle on one pad and Ares 1X getting ready to roll out to the other pad, there really are major conflicts with personnel. And so we got to a point where we couldn't do both. And so we needed some higher level agency support to help us determine where the priority lie. Making that decision at a little bit earlier time frame would have allowed for operations here at KSC to be more easily deconflicted if we knew those priorities a little bit earlier.
One of the other things we learned from in the firing room during our testing and validations, as well as during the launch countdown, was the proximity of the different systems to each other. We had a lot of systems that were clustered very closely together, and as a result of that, when they were communicating over their headsets to the other folks in the field, there was a lot of over-talk from the folks next to them because they were in very close proximity. I think the lesson learned would be to provide a little bit more space to those engineers that are in there trying to implement launch commit criteria, and also to perform the work that they need to do with the technicians and engineers in the field. And one of the other things that we also learned was we had a single string team of individuals working in the firing room side by side, which also on very long days when we were doing some of our integrated system testings and other interface verifications and things like that, made it difficult to give folks breaks or times off console when they needed to, when they're there for very long extended periods of times, because we were single string. Certainly we could cover for some of those people utilizing other systems, but the co-pilot approach is certainly one that is the recommended, if it's at all possible, approach to allow individuals to have the ability to get off console during a major integrated test so that it does not disrupt the testing itself. Likewise, with that co-piloted approach, we were also implementing, aside from the procedures and the work and console commanding, we utilized electronic procedures, which took almost a dedicated person to go through and procedurally validate that the steps had been performed as we went along through the task. Even though they were electronic and certainly very quick and a much better approach than using hard copies of paper, it still took quite a bit of time from the operator's perspective to be able to utilize those business-type systems that were used in parallel with the engineering systems. And so the pilot-co-pilot approach does give you a lot more time to focus in on the engineering and technical side of it and not just working on the procedure side of it as well. One of the more significant lessons learned for us as a launch team and as a team trying to ready the vehicle and all the systems and validate them, it was the training perspective. Putting together good training requirements for the teams was essential so that they could start the training process to make sure that we had the people with the right skills, the right certifications, and all the right tools that they needed to do the tasks that we needed on the 1X vehicle. Starting that process early from at least establishing the requirements perspective was very important and something that we did this time and certainly would want to do again in the future to make sure we had those folks together. The other side of the training was the actual sitting down as a team and validating the systems themselves as we went through much of the system validations. But far prior to that, we did procedure validations in which we would run through the procedures and make sure that they would work in the order in which we had put them together, and that they would work against the hardware that was out in the field, that not the Ares 1X hardware, but the stuff that was back at some of our labs, and running the hardware against that using our software commanding from the firearm. So that training was also very vital for two reasons. One was to get the console operators familiar with the ability to command the systems and the responses that they were going to get back, because a lot of this was brand new hardware that they hadn't used in the past. And then the other thing was to develop a test team concept/approach so that the team could learn how to work together. From my perspective as the head of that team, that was very vital to me and for a lot of folks. The ability to communicate with each other day in and day out over the headsets makes for a better team that's going to be able to do that on launch day in the heat of battle when time is even more critical and you're set up against timelines and launch constraints. So that part was extremely important. We did an awful lot of training that engaged portions or all of the test team. Sometimes we did certain groups and sometimes we did the team as a whole, and it varied based on what we were trying to accomplish on that particular day. But I think the training portion certainly was key to allowing us to function as a test team on launch day, and it's very important in the future. To go along with the training requirements that we put together, the understanding of who the people were that were going to be involved with the test team, identifying those early, we also learned was very important, because we had to make sure and ensure that folks had all of the proper training that they needed, and there was a significant amount of training. Some of it was within their knowledge base and some of it was not, that we had folks that had to go out and retrieve some of this. This was a new vehicle. There was a lot of new requirements out there just as to how the program was working, how we were going to implement PRACA, when we had corrective actions, when we had all these different things. So there was a lot of training that had to be done for folks. Identification of personnel very early in that process is very helpful so that they can get that training. We can go through and practice with them in advance. In addition, at the end of all of the training that they need to do, including sitting on the console, running through a certain number of simulations with a smaller team, with a broader team, we go through what we call a stand board process, in which a group of individuals, and there's a chair in that group, who in this case was myself, go through and ask a series of questions, a series of scenarios, and to determine the expertise of the particular individual and to what level of certification that they would be ready for to support the rest of the team, whether it was just for day-to-day testing, whether it was integrated testing, or whether it was launch countdown. because part of our goal and responsibility was to choose the best person for the job. That was always our going-in plan, and to make sure that we had the best and most trained team that we could support all of those different functions. And I think we did a pretty good job of that overall. At times it seemed like there was an awful lot of training and different things going on, but certainly it helped to establish a very clean and crisp team that worked well together. And I think it was also helpful to be able to determine who, in fact, were the best people that we could put on console for launch day. One of the specific things that we did in 1X was we had a large number of centers represented doing significant portions of work, either designing or building portions of the Ares 1X vehicle. When those parts of the bigger piece were done, all of the hardware came here to the Kennedy Space Center for eventual assembly, testing, and launch. When that hardware came here, a lot of the hardware also had the technicians who were building it. Some of the builds weren't 100% complete. We had to outfit them with instrumentation and other types of things to get ready for the integration with the other pieces as well. So there was a large number of people who hadn't worked in the KSC environment, hadn't worked with the other team, for example, with the folks who put together the solid rocket booster or maybe the upper stage or some of the other components. So what we did, and I think it was helpful to the team, was we sat down and had training sessions with them and orientation sessions on how to do business at the Space Center as a whole, what were the expectations, what are the training requirements, the safety concerns, all of the different things to help acclimate them to the environment in which they're going to work in. And then on top of that, we also spent a significant amount of time training them to understand the types of electronic tracking systems that we were using, corrective action systems and those types of things, so that they were aware of all of those things that they were going to be working with, because they were completely different from the environment in which they had maybe been working for many, many months or even years putting together this hardware.
One of the lessons that we learned with a flight test like Ares 1X, when you've got folks from multiple centers and multiple contractors and organizations coming together at Kennedy Space Center to not only build the rocket but also to do the integrated testing and launch, they all come from different environments at their centers or their different areas of expertise that have different operating procedures and different standards than Kennedy Space Center. And so one of the challenges that we had, not only for that piece of it, but also that we were using space shuttle program facilities, the VAB, the launch pads, the HMF, all these areas were also processing space shuttle hardware. Getting all those folks who are coming from different centers familiar with the emergency procedures, safety procedures specific to the facilities that they would be working in was also a challenge. We had to get them trained and familiar with those areas before we could just let them go off and go do their work.
I would hope that as we go through to the next vehicles for 1Y or anything else that's out there, that we look back again, we look hard at what we did in 1X and what we've done in other vehicles, and take the best that we've done out of all of those and try to implement and incorporate all of that as we are here with this lessons learned, and use those so that we don't, run up against the same obstacles and roadblocks again. Sometimes there's a tendency to collect a lot of information, but then we don't do a lot with it. Far more important than getting all the data is using the data that you get. And I think that is the most important thing. And I always try to make sure when we have lessons learned that come out of things that I've worked on in the past, that we go out and make a concerted effort to go off and change what it is we're going to do again. Change the procedures, change the philosophy, change people's minds if possible, and try to use it as sort of your wake-up call to go off and do what needs to be done. Because I think in the grand scheme of things, when it's all said and done, and you're out there on launch day and you're looking up and you're watching a vehicle go and you know that you had some part to do with that, I mean, that is the reward. There's very few jobs out there where you get the satisfaction of looking at the final product that you've done and that you've worked on for so long, and to see it go off, and especially to ride up on a column of fire up into the sky. I mean, that is the most amazing feeling in the world, and all of us are lucky and should be feeling very proud to be part of any of the programs that we have out here that allow us to do that. So.